Now we're going to look at the topic of modelling in differentiation. So this is anything where we're using differentiation in context. So for instance, slurry entering and exiting a tank, I could look at the change in volume with respect to time, or dV by dt, the rate of change of volume with respect to time. We can immediately apply this in context in questions. So here I have a sphere of volume V expanding. I want to find the rate of change of volume with respect to radius, so that is dV by dr. At the point where the radius is 3, is going to tell me to evaluate that at the point where the radius is 3. Now, since I know that the volume of a sphere is given as 4/3 pi r cubed, all I need to do is differentiate that with respect to r, which is going to give me 3 times 4/3 pi r squared. Bring the power down to the front, reduce the power by 1. Tidying things up, I've got 4 pi r squared, and differentiating that at the point where r is 3 would give me 4 pi times 3 squared, which is 36 pi. It can seem a bit strange initially to start differentiating with respect to other values, but you'll quickly get used to it. Other common things are thetas, so theta could be t to the power of 5 minus 4t squared plus 7 or something, and we can find d theta by dt in exactly the same way. We would just differentiate, so 5 down, reduce power by 1, then 2 down, reduce power by 1, and then the constant would disappear. More complicated questions. So in this question, we've got an open box that's constructed from 5 sheets of card with a total area, given that 2 faces are square, and my apologies, 3 are rectangular. Find and justify the maximum volume of the box. So we've got a box where we've got a square on one end, so let's just try and draw this out, and we're going to have a square on the other end, and then we've got sort of 3 rectangular faces. So we've got 5 pieces, 1, 2 on either end, and then 1, 2, 3, but no top on this box, if you can imagine what that might look like. We want to find the volume of the box. Well, let's start off with the square, so we could label that x and x, and then we've got another side on our box, so let's label that L, and we can make an equation for the volume of this box, which is going to be x times L, or x squared L. I can also work out the surface area of this box, because that would be the 2x squared sides plus the 3 rectangular sides, which are all of area XL. I actually know that the area of that box is 24 centimeters square, so that becomes 24 is equal to 2x squared plus 3xl. And what I'm going to do now is to rearrange this equation until L is the subject. So 24 minus 2x squared is going to be equal to 3xl. 24 minus 2x squared divided by 3x is equal to L. And now what I can do with my first equation and this second equation is I can substitute my second equation into my first. Now, the neat thing about this is it's going to eliminate that value L that I previously didn't know and leave me with x squared lots of 24 minus 2x squared all over 3x. A bit untidy here. What do we have now? Expanding that is going to give me 24 over 3 is 8. X squared divided by x is x minus 2/3. X squared times x squared is x to the 4 divided by x is x cubed. So that gives me a nice neat little equation here for the volume. Now what I can do is I can find out how the volume would change as x changes. So dV by dx. So differentiating that equation with respect to x is going to give me 8 minus 3 times 2/3 of x squared, or 8 minus 2x squared. Now if I want to find out the maximum volume, I know that maximums happen when the rate of change happens to be 0. So I want to try and solve 0 is equal to 8 minus 2x squared, or to say that 2x squared is equal to 8, or that x squared is equal to 4, so that x is plus or minus 2. Now, because x is a length, here the value minus 2 is absurd, because you can't have a negative length. So I know that the value of x should be 2. The questions ask me to justify that this is a maximum. Well, to justify maximums, I need to look at second derivatives. So I need to look at d2v by dx squared. The second derivative is just going to be minus 4x. Now, if I evaluate that second derivative, at that value where x is 2, I end up with negative 8, which is less than 0, which tells me that what I'm dealing with is a maximum. So there's my justification. All that's remaining for me to do now is to find out what that maximum value is. Well, for that I just need to work out what v is evaluated when x is 2. So that's going to be 8 multiplied by 2 minus 2 times 3 times 2 cubed, which is 16 minus 2/3 of 2 cubed, which is 8. 16 as thirds is going to be 48 thirds, and then that's going to be 16 thirds, and 48 minus 16 thirds is going to be 32 thirds. So there's my maximum volume, and that's me done for these questions.